Hello everyone, happy Diwali. And with this, I have brought a very important information for your ISC chemistry practical exam. Some very important tips which you need to remember when you are writing your practicals. So without wasting the time, let's start. We all are aware that in your chemistry practical ISC, you have got three questions. Question number one belongs to your physical chemistry, which can be your titration, it can be chemical kinetics, it can be electrochemistry, but mainly we do the titration in the schools. So let's discuss about titration, which carries 7 marks. Now in the 7 marks, there are 3 marks for your titer value, and 4 marks are there for the four subparts, where either the question says that you have to calculate the value of X, water of crystallization, like the question can be given as suppose I'm taking oxalic acid and KMNO4 titration CH2C2O4 dot XH2O. So this will be printed, or they will use the term impure KMNO4 or impure oxalic acid, where you have to calculate the percentage purity of the solution as per the question demands. So let's start with the question paper. The very important to read the language of the paper. There is one instruction given where you have to record the size of the pipette. Now the question paper says pipette out 20 or 25 ml. Let me tell you children, this should not be the individual choice. It should be totally the instruction given by your subject teacher, whether you have to use 20 ml or 25 ml, because collectively every student should have the same value. Like I always instruct the children to use 25 ml as the size of the pipette. So this is one thing. Second thing is your observation table, where you need to be very, very careful, because the second part says record the titer value. For this, when you are making the observation table, like I am using the running hand because I'm using a digital board, so you can see the lines are not straight. But then when you are doing it for your board examination, please carry the proper stationery. It should be the proper table which should be drawn with the ruler and pencil. Your first column says initial reading. Now, initial reading is the reading when you are starting the practical. Now, when you are starting the practical, you will not get the titer value immediately. So, your first initial reading should be 0.0 ml. Unit is very, very important. Like this, you have to write 0.0 ml. Now, please do not write 0 ml. This is wrong. You have to write 0.0 ml with the decimal. Then comes your final reading. Now, in your final reading, they say record two concordant readings. Two concordant means two similar. So, suppose I am getting as 24.3 ml. Again, unit is very, very important. You have to write the unit. So, 24.3, 24.3. Suppose my third reading was different. It is 25.0 ml. Then comes your end point, which is your titer value. Now, the two concordant readings are these. So my titer value will become 24.3 ml. So this observation table I will draw. Then I will write the header titer value equal to 24.3 ml. Again, unit is very, very important. You cannot mess up on the unit. It's really very important. So let's see the other four parts which comes to calculate. Now, in the other four part, when it is coming to calculate, you have to be again very, very careful, because they say that you have to write the formula, you have to write the substitution. Using a scientific calculator in ISC doesn't mean that you are doing the direct step. You will not get the marks. To get the marks, there should be at least 2 single ticks per part to get the marks. So now suppose if I say your first part, if I am calculating for X, so the first part will be calculate the molarity of KMNO4 solution, the first part. Now you have to remember one thing very tactfully, children, that whether it is your percentage purity or it is your X, The first part formula will be molarity is equal to strength upon molecular mass. This is the first formula for the first part, whether it is X or percentage purity. Now here when you are calculating the molarity, the value should be till 4 places of decimal. It is mandatory. 4 places of decimal. You cannot write the value till 3 places of decimal. Is it clear? This is something very, very important. Now, suppose my answer is coming 0.0034567. So 4 places of decimal means 1, 2, 3, 4. I will see the value which is there on the 5th place. Now, if the 5th place, the value is less than 5, we will ignore. But if it is 5 or more than 5, the answer will become 0.0035 and capital M you have to write. Then only you get 1 tick for this, you get 1 tick for this. You have to write the correct substitution. You cannot do anything. If you are not sure that you will be able to write the correct value for 4 places of decimal, in that case, whatever answer you are getting, you write that with capital M. Suppose your answer is coming 0.010 only. So you cannot say that my answer is 0.010. So I have to write only till here. No, you have to add 10 and then write capital M. Then comes your second part, the molarity of the second solution. Now, when you are calculating the molarity of the second solution, children, then in that case, the formula will be M1 upon M1 into V1 upon M2 into V2. So in that case, it will be M1 V1 upon M2 V2 is equal to N1 upon N2. Now N1 upon N2, you have to write here burette reading and here you have to write the pipette reading. Your numerator will always be the burette reading. Your denominator will be the pipette reading is equal to N1 upon N2, where N1 will be the number of moles of KMnO4. That is why an equation, balanced equation is printed in your paper. Your entire procedure for titration is printed in the paper. So you have to read the paper carefully. You will get everything from the paper. So M1 is the molarity which you have calculated from the first part. So you write that value into V1. V1 is your titer value which you have recorded. Upon M2 you have to calculate. Your V2 will be the size of the pipette. So size of the pipette is 25. Now we are taking 25. Suppose we are taking oxalic acid versus your KMnO4 versus oxalic acid, then N1 upon N2 will be 2 by 5. You can see from the equation. So you equate, again you will get the value for N2. Now this M2 which you are calculating, children, again you have to be very careful because again the same condition applies that you have to use the 4 places of decimal as the answer. You cannot write the value as per your own convenience. So this you have to be very, very sure that whatever you are writing correct. So again, M2 will be till 4 places of decimal value. Then comes your third part. Now your third part, if they are asking X, your third part will always be the calculation of molecular mass. Now molecular mass, you will be calculating by the formula. You have seen in the first part, molarity was strength upon molecular mass. So your molecular mass will be strength upon molarity. Now, in this case, what you will do is strength upon molarity. Molarity will be the molarity of oxalic acid because the question says H2C2O4 dot X H2O. Water of crystallization you have to calculate. Because of this X, you cannot use the simple manual calculation for molecular mass. So you have to use this formula, strength upon molarity. Molarity for oxalic acid, you have calculated from the second part. You will substitute, strength is given in the question paper. You will get the molecular mass. Now here, the unit for molecular mass will be gram per mole. This is required. So this is your third part. Now the moment you calculate, children, your third part, you have calculated molecular mass, then you will calculate your value of X. So for value of X, again, formula is required. So you can simply write molecular mass of, I am writing oxalic acid because I don't know what uh, in your question paper, what code they have mentioned. So because I am not knowing the code, therefore I cannot use it. So suppose A1, C1, C2, C3, C4, whatever is written, accordingly you will be doing. Suppose I have calculated the molecular mass, and the molecular mass is coming as 123 or 125, whatever it is. Then in that case, what you will write? Molecular mass of oxalic acid, you will write H2C2O4 dot XH2O is equal to, suppose I have calculated as 127, it is coming. I'm just giving an hypothetical value. Then for H2C2O4, for this particular part, you will calculate. So this part will come as 90. Plus, we know that the molecular mass for water is 18. So it will become 18x is equal to 127. You will calculate x. Now, suppose x is coming as 2.3. You cannot leave water of crystallization in a decimal form. You have to use it in the approximate value. So your answer will become 2. If it is 1.7, then also the answer will become 2, because the correct answer is 2. So you cannot leave your answer midway, children. So you have to be very, very careful that when you are writing your water of crystallization, you are rounding it off. You don't round it off, you will get 0 for that particular part, because the examiner will write a comment that water of crystallization cannot be a decimal value. So you have to be really very, very careful that what you are doing. Is it clear? Now, these are the 4 parts when you are calculating your water of crystallization. Suppose if it is percentage purity, so for the first part, the formula will remain the same, which I have discussed, strength upon molecular mass. Second part, again, the formula will remain the same, M1 V1 upon M2, V2 is equal to N1 upon N2. Third part will change. Here, the third part was calculation of molecular mass, but in case of percentage purity, your third part will become the calculation of the strength of the impure solution, because the strength which they have given in the question paper, that is of impure solution. You have to calculate for pure solution. So for that, you will use the formula strength is equal to molarity into molecular mass. Now suppose the question paper says that it was impure KMNO4 solution. And for that, suppose the molarity you have calculated from the first part was, sorry for this, from the second part, because it is KMNO4. So you will use this formula. M1 V1 upon M2 V2 is equal to N1 upon N2. Now in this case, 0.0234. This is the molarity which you have calculated. So you will write 0.0234 into 158. 158 is the molecular mass of KMNO4. Whatever answer you will be getting, it will be, the unit will be gram per liter. Is it clear? The strength which is printed in the question paper is grams per liter. So you have to be really very be careful for the unit. Then the fourth part will be the percentage purity. Now for the percentage purity, again the children, they miss upon or writing the formula, where the formula is very, very important. They will not give any flexibility while doing the correction. If the formula is missing, then you are losing your marks again. So in this case, when we are doing the formula will be for percentage purity, it will be calculated strength, which you have calculated from the third part, upon given strength, which is printed in the question paper, into 100, because it is percentage purity. Your answer should be less than 100, because percentage means something which we are calculating out of 100, so it should not exceed. If it is exceeding, that means you have made a mistake. Now, coming back to your question number 2. Now, question number 2 is very, very simple, organic. Whatever of the experiment part is printed in the paper, you have to just note down the observation. Like, for example, if I give acetone, suppose it is. Now, in acetone, there is one test that to the given organic compound, please add sodium nitroprusside solution and sodium hydroxide solution. So, in that case, you get a red coloration. If you are getting a color, you have to write a color only. You cannot write PPT. If you are getting a PPT, you have to write PPT. These are the two main things which they concentrate upon, ki precipitate or color. If you miss upon the observations, then you don't get the marks. Then once you have written the observations for all the parts, in the last you have to write what is the given organic compounds. If it is acetone, then you are writing your answer as acetone, and then you should also draw the structural formula. In case you miss upon writing the compound's name, but you have written the formula, you will get the marks. Otherwise, you will be losing the marks. To get the marks for the correct deduction, your 2 observations out of the 3 should be correct. If only 1 observation is correct, you don't get any marks for the result. So it is mandatory that at least 2 tests should be correct when you are writing the observations for your organic compound. So out of the 3, 2 tests correct, you get the marks. The 2 marks for compound 1, and similarly for compound 2, again they will give you 3 tests in the paper. You have to perform, you have to write their observation. Same condition. To get the marks for the result, you have to write the 2 observations correct at least out of the 3. If all the 3 are correct, well and good, you will get full marks. That is the best part. Question number 3, qualitative analysis. You have to remember that zero group is done directly with the salt. It is not done with the original solution. The first thing you should do is that take a little amount of the salt separately in a test tube. You add dilute any of its solution to it, heat the contents. After heating the contents, you add Nestler's reagent. While you are heating the content, then only the solution will smell of ammonia, but that is a preliminary test. You have to add Nestler's reagent. Now, I said add Nestler's reagent, which is a wrong language. You have an ammonia is a gas, we cannot add anything to the gas. So once you are writing your practical, you have to write pass the evolved gas through Nestler's reagent, solution turns brown. That means you're given group 0 is confirmed. First we write the confirmation of the group, then we write the confirmation of the cation. That is the basic radical. So you will write 0 group confirmed. Below that you will write NH4 plus ion confirmed, because for 0 group and ammonium ion confirmation, the same test is applicable. If 0 group you are getting, then rest of the basic radicals you are not required to do. You are the most lucky person that you are getting the easiest practical. But yes, if 0 group is absent, then you have to prepare original solution. Original solution is prepared by checking the solubility in the distilled water or in the dilute acids. We don't use dilute H2SO4 because sulfates are insoluble. Similarly, when you are doing the test for the anions, we have to write sodium carbonate extract procedure 1:3 ratio. Then you have to neutralize the soda carb extract and perform the test. Sodium carbonate extract is applicable for your sulfate ion test and for chloride ion test. For nitrate ion copper turning test, we do directly with the salt. NaC is not required. Similarly, when we are doing for carbonate ion test, NaC is not required. So there is no need to mention, it is done directly from the salt. So you have to really see that which anion has been given to you. You have to be very, very careful that when you are writing, suppose if you have got 6 group, that means when I have added group reagent of the first group dilute HCl, no PPT obtained, no change. You have to write the absence of the first group. Group 1 is absent. In the same solution, you will pass H2S gas. No observation recorded. Group 2 absent. In the same solution, you have to add solid NH4Cl in excess followed by NH4OH solution. No observation recorded. Group 3 absent. In the same solution, again we pass H2S gas. No observation recorded. Group 4 absent. In the same solution, we add again solid NH4Cl followed by NH4OH solution followed by ammonium carbonate solution. You don't get a PPT, group 5 absent. Then again we make the solution alkaline by adding solid NH4Cl, ammonium hydroxide solution, and this time disodium hydrogen phosphate. I get a white PPT, that means group 6 is present. And below that only we write magnesium ion present. Why? Because again for magnesium and group 6, the test is same. But first we will record the presence of the group, then the presence of the cation. I have mentioned these because if any of the groups are present, before that, whatever groups are existing, you have to write that test, you have to write no observation or no change observed, and in the inference column, you have to show the absence of the group. Then only you will get the marks for the present group. Otherwise, children, you will be losing your marks. So all the best. I hope this video will be helpful for you to prepare for your practical exams. So best of luck. Just stay tuned for the rest of the important videos. Thank you.